In this lesson, we're going to be learning Pythagorean Theorem and classifying whether or not a triangle is acute, right, or obtuse. So on this first problem, we are going to be solving for the length of x. This is a right triangle, so that lets us know that we can use Pythagorean Theorem to solve for the variable. Now in the Pythagorean Theorem, I'll go ahead and just grab an extra sheet of paper. When you have a right triangle, okay, across the 90 degree is always C, or the hypotenuse, leaving you with A and B as your other sides. The Pythagorean theorem is A squared plus B squared, and that's always going to have to equal C squared. So this is the Pythagorean theorem, where C is always the hypotenuse, and we're going to be using the Pythagorean theorem to solve for missing side lengths in a right triangle. So let's go ahead and get started. The first thing you're always going to want to do is label the triangle. Find the 90, go across from it, and put a C, standing for hypotenuse. From here, I'm just going to label as A and B, and it doesn't matter if you label 7 as A or B, because we're going to square them and add them together. So it doesn't matter as long as you have across the 90 as hypotenuse. So I'm going to write my formula, A squared plus B squared equals C squared, and I'm just going to substitute. A is 7 plus B is 3, and C, you can leave it as C or change it to X. It's your choice. From here, I just square. Okay. So I'm going to have 7 squared is 49 plus 3 squared is 9 equals X squared. Okay. The square root, or 49 plus 9 is 58 equals X squared. And then I square root. To undo a squared, you always square root. The square root of 58 is a decimal, so I'm going to leave it as just square root of 58. So the length of the hypotenuse is the square root of 58. You can do this individually, or you can actually go ahead and just type 7 squared plus 3 squared into your calculator, and it will give you 58. So you can save yourself some time by just typing that straight into your calculator. Now you can only type it straight in if the variable is isolated on one side of the equation. Okay, let's try another one. So the first thing you're going to want to do always, all the time, is to label your triangle. Across the 90 is the hypotenuse, and then it doesn't matter which one you make A or B. So again, I'm going to write the formula, A squared plus B squared equals C squared. My A value I've labeled as 5, so 5 squared plus my B value, X squared, has to equal my C value squared, which is 10 squared. Notice how the variable is mixed in with the plus, so you can't just type this straight into your calculator. You can't just do 5 squared plus 10 squared, because it's not going to give you the correct answer because we're not adding them together. So you want to simplify by hand here. 5 squared, 5 times 5 is 25, and then I'm going to bring down that x squared. 10 squared, or 10 times 10, is 100. Our goal here is to isolate x squared, so in order to do that, I'm going to move the 25 through subtraction. That cancels. I'm going to bring down what I haven't used. 100 minus 25 is 75. To undo the square, I square root, and when you square root 75, you get a decimal. So we're going to leave it as square root of 75, and that is your B value. Okay, the Pythagorean theorem can be used for multiple other things, such as determining what type of triangle you're working with. So when you're given 3 side lengths, you can determine whether or not the triangle is right, acute, or obtuse. So let's review that really quick. If a triangle is considered a right triangle, A squared plus B squared has to equal C squared. If the triangle is acute, meaning all angles are less than 90, A squared plus B squared has to be larger than C squared. And if the triangle is obtuse, meaning one angle is larger than 90, A squared plus B squared must be less than C squared. So if it's a right triangle, they have to be equal. If it's an acute triangle, a squared plus b squared must be greater. And if it's obtuse, a squared plus b squared must be smaller or less than c squared. So let's use this to calculate and determine what type of triangle we have down below. So determine if the triangle is acute, right, or obtuse. So let's start the first one. The first thing that you have to make sure that you do is identify the hypotenuse. Now, even though we don't have a picture of our triangle, we should always know that the hypotenuse is always the biggest number. So my largest number here is 14. That's my C value. The other two are going to be A and B. So I'm going to plug this into Pythagorean Theorem. 12 squared plus 6 squared equals 14 squared. You can do this straight into your calculator, which is perfectly fine. When doing this, you want to make sure that you're just breaking it up at the equal sign. So I'm only going to do 12 squared plus 6 squared to get 180. I'm not going to simplify the 14 squared yet. I'm going to break it apart. So 180, then I'm going to do 14 squared, and I get 196. 196 is larger than the 180, so that means a squared plus b squared was less than c squared. So looking back at our chart here, okay, this is from our previous problem. Looking back at our chart here, when a squared plus b squared is less than c squared, that makes it an obtuse triangle. So we're going to classify this triangle as obtuse. Okay, let's try the next one. So on the next one, we have the lengths of 15, 12, and 9. The hypotenuse here would be 15 because it's the largest value. I have 12 and 9. Those are going to be my A and B value. So 12 squared plus 9 squared equals 15 squared. Again, I'm going to do this straight into my calculator. So I'm going to do my 12 squared plus 9 squared, and I get 225. Okay. Then I'm going to go ahead and do my 15 squared separately because the equal sign kind of broke it up. I'm going to do half and half. And notice how we also got 225. 225 is equal to 225, and if we get the same number on both sides, if a squared plus b squared does in fact equal c squared, that means that the triangle is a right triangle. So we're going to go ahead and classify this as a right triangle. The very last problem that we're going to do here is, let's slide on over. We have a side lengths of 7, 24, and 23. So in this problem, let's go ahead and identify hypotenuse. The largest number is 24, so that's our C value, leaving us with 7 and 23 to be A and B. 7 squared plus 23 squared equals 24 squared. I'm going to go ahead and type this straight into my calculator. So 7 squared plus 23 squared gives us a total of 578. I'm going to also do my 24 squared, which gives us a value of 576. When comparing the two, the a squared plus b squared is a little bit larger than our c squared value. So what that means is when I compare, when a squared plus b squared is greater than c squared, which it is, the triangle would be classified as acute.